So we talked about normal distribution and everything that's associated with it, right? Like we know a lot of things when we're told that normally something is normally distributed. Okay, I have to tell you that in real life, it's not as smooth as this curve is. Because technically, when you did the histograms, we did histograms, and then when you did your bar graphs, they resemble this bell curve. And so that's kind of what we're talking about. If we were to have a bunch of bars here, and then were to connect the tops of them, we would kind of get this smooth curve. And then we would say, hey, this is normally distributed. And we're going to do that at the end. We're going to prove or show whether or not data indeed is normally distributed. For now, you just guarantee that everything is. So we realize, or we know that the mean is right at in the middle, that 50% of the values are to the left, 50% are to the right. That's very important for you to know. And you're like, well, what about, you just say 99.7%, Mr. Dirksen. What about that? I don't see 100 here. Well, 100, right, if you were to include the little wings here, right, that the 0.15, right, if you add that to this, then you do indeed have 100%. But we kind of we tend to focus on 3 standard deviations to either side. That's where we kind of say, like, you know what, most of our data is going to be within that. And so we know percentages in between. And remember, guys, these bars could be really wide, it could be narrow. What determines that is your standard deviation determines that. So my graphs, they kind of always look like this, but in reality, if you were to draw it to scale, you would have a flatter curve versus a steeper curve. Okay, sometimes the bars would be spread out. Like, for example, if we had a different country, right, and let's say that standard deviation would be 5 centimeters, right? Then we would go, okay, this is your mean, then we'd go 5, 5, 5. So technically it should be twice as wide, right? Every gap should be twice as wide as this one. Okay, so let's keep answering. And I asked you to try 26, to just try to answer those questions, right? And it's always based on this graph here. And we answered all the way to D. So let's continue with page 26. And I know you weren't able to do them all, but at least you read the questions, okay? It says, what is the range of heights for 99.7% of males? This number should stick out to you. It should really tell you, hey, that number, remember that one? It's not just a random one, it's actually specifically back to the graph, right? So we want basically, the range is you want to go the lowest to the highest. So I know you're going to be like, okay, range, I remember mean, median, mode, range. Range is subtracting them. But in this case, they just want, like, what are the 2 heights where 99.7% of the males would be encompassed in, right? So the lowest, let's go to our graph. The lowest we determined is 169.5, and the highest is 184.5, right? These 2 heights will have 99.7% of males within it. So 169.5 and 184.5 centimeters. By the way, you could have done this without the graph, to be honest, because this is the mean minus 3 standard deviations. This one is the mean plus 3 standard deviations, right? This is just in brackets so you understand, right, that you could get this number if you knew your mean and your standard deviation, right? And it was 177, right? So 177 minus 3 times 2.5, that gets us to the lowest point, and then 177 plus 3 times 2.5 gets us to the highest point. So we know that 99.7% of males would be within these two heights. Okay, that's what it's asking for. What about 95%? Okay, so this is 99.7, 95%. I'm going to go off track here a little bit. We know that if it's 95%, we're looking at mean minus 2 standard deviations, right? And mean plus 2 standard deviations. Those are going to be the two heights we're after. We're just going to read it off of the graph. Okay, so let's go find 95%. We know that 95% is from here, from the left to the right. So I'm just going to go down the graph and just copy 172 and 182. Okay, those are the two heights there. 172 centimeters to 182 centimeters. And then for 68, 68% should tell you, oh, I'm going from mean minus 1 standard deviation and mean plus 1 standard deviation. Okay. So that would be, I'm just going to go peak, right? 68% is from here to here. So it's 174.5 to 179.5. That is the range of that we're looking for here. Don't subtract it when it's within this context, when you're using the normal curve, okay? So 95% of males would be between these two heights, and 68% would be between these two heights. Okay, we would say within 3 standard deviations. The word within, guys, within means on the low end and on the high end 3 standard deviations. So it's really, think about it, we have between the -3 and the +3, there are 6 standard deviations between. Here, -2 plus 2, there are 4 standard deviations that we're considering. -1 plus 1, there are 2 standard deviations that we're considering. Your head spinning already? Next, if Canada has a male population of about 17 million, okay, determine the number of males that are shorter than 172 centimeters. Okay, watch out. You're not just asked to find a percentage, you're asked to find the number of. Okay, so we're going to do this. Probability of males being, probability of males being shorter than 172 centimeters. What would that be? Let's go to our graph. I'm asking you to base it on your graph. So let's go find that. There's a chance that this 172 is going to be somewhere along the x-axis. So let's go find that. And 172 is right here. So I need to add, so if you want males that are shorter than the 172, you need to add the percentages to the left of it. So 2.35 and 0.15, right? That is the chance of someone being shorter than that. So that'd be 0.15% plus 2.35%, which is 2.5% chance. The likelihood of someone being shorter, a male being shorter than 172 is that. That's the chance, but you want the number of. As simple as this. Number of, right, would be 0.025, right? You divide this by 100 to get your decimal, and you multiply that by 17 million. And I completely revamped this booklet, so some of it matches my old key, but not all of it. So in this case, it is a whole number. Round if it doesn't, okay? are expected to be shorter than 172 centimeters. You would be, if you went into any industry, whenever they make something like a roller coaster or any of those rides, they go by what is most common, right? Like how high should we have that bar that locks your legs in place, right? All those things. Cars, when they build the seats and how far back you can go, how high above your lap the steering wheel will be. Of course, you can adjust that, but it's based on stats, right? Okay, what percentage of males? There it is, percentage of males have heights with a z-score. What's that? So this is important. Keyword, percentage of males. So not number of, just percentage. Have heights with a z-score between -2 and 1. Okay, I want you to see that you can use z-scores or the actual heights. Okay, so let's go and look at the z-scores. A z-score of -2 corresponds to a height of 172 centimeters. And a z-score of 1 corresponds with a height of 179.5. So basically, you just want the percentages from here to there, right? That's all you want. So I have to be careful here, -2, so from here to here. So I'm going to try to memorize those numbers. 68 plus 13.5, right? 68 plus 13.5. Let me help you out here. I'm going to do this. This is 0, -1, -2, and this is 1. And basically, we know that there's 34, 34, and 13.5. I just keep it very simple. What's the height associated with -2? Sorry, I got a peek here. 172, 172 centimeters. And plus 1, 179.5. This is overkill. I know I'm over, this is too much sometimes, like I think you get it, but I want you to see the relationship between the z-score and the actual heights. So this is the same thing as saying what percentage of males are between 172 centimeters and 179.5. It's the same thing. We can go from here to z-scores to here every time, okay? So let's just get right to it, okay? Do I have that? So 68 plus 13.5. I don't want to get this wrong. There we go, 81.5% of males. Okay. So the z-score here, z-score, so z-score. And I just focused in, right? I focused in on from here to here, right? I don't care about the rest of the curve. I just want that, okay? What is the range of heights that would have 95% of males comprised in a copy, right? That's a copy. That is actually going right back to here, 95. So the 172 to 182, okay? Let me see what I can do with this though. 95, that's from -2 standard deviations to +2 standard deviations, right? That's what that is. Actually, let's go x bar. Sorry about that. So that's 177 minus 2 times 2.5 to 177 plus 2 times 2.5. And I'm just going to copy our answer above. This is my answer. This is if you don't want to use the graph. But if you already have the graph, just go get those numbers, right? And you're good. Can I say something? This question, I will never do this to you. What heights have 190, or sorry, 90% comprised within it? You don't know that, right? You can't guess that. It's going to be one of those 68, 95, 99.7. Once these numbers change, we're going to have to use our calculator for that, right? If I asked you what has 90% of males within it, what are the heights? Then you're going to have to use this. Okay, so we're getting there, but for now, we're just basing it on what we know. Okay, let's keep going. Do I have to, if the mean, yeah, this one is good. The mean, if the mean height of females is 162.5 centimeters with a standard deviation of 3, I want you to sketch both curves on the same plane. How will they differ? Use different colors or patterns to illustrate this. Okay, let's do this. Let's organize our data here. Males, females. Mean standard deviation. So this is 177, 2.5. And here it's 162.5, 3 centimeters. I'm just doing this to make my point. Okay. This one tells you the location. This is location along the x-axis. That's what the average tells you. Where on the x-axis is the data going to cluster? And this one is going to tell you the spread. Okay, scale or spread. This is scale or spread. This one will be clustered, steeper. This one will be wider, flatter, because of the standard deviations. Because of the standard deviations. So let's try this. This is our, and you don't need to have a pretty graph. This is just to illustrate, to sketch, right? So it'll be the heights in centimeters. And maybe I will use a highlighter for each. So males is there. You'd have to realize that 177 would be right here. And 162.5 would be somewhere here. Right? These are my two averages. So I'm going to start with males first. It's going to be clustered and steeper, so that's going to be a higher max. Just put a dot there, and then I go from there and make my curve like this. That's good enough. So I make the point right on the above the mean. I make a point and then I go to the left and to the right, try to make it as symmetric as possible. And for females, we're going to go to that mean because that's where most data is going to cluster. And we're going to make it lower than this one. We're going to make it flatter. So don't go and match the same height, just go lower. Right? And then we're going to go like this. Okay. There we go. That would be the main difference. The mean told us where along the x-axis that graph is going to be. And the standard deviation gave us information on how flat or steep. So this one does look a little flatter than that one, right? Again, sketch it and you'll be fine. And for the next part, I need to give you formulas for this next one. I skipped that yesterday, okay? It asks you, calculate the z-score of a male with a height of 181 centimeters. What does that tell us? So let's go back in time a little bit to 25. I'm going to give you those formulas at the top here. And this is what I call calculate the z-scores by hand. You should have this on your study sheet for sure. To find the z-score, we just call it z. You go value minus the mean divided by your standard deviation. Okay, where x is the mean. Obviously, this is standard deviation. And this is the value considered, actual value. Actual value. On the other hand, if the z-score is given, write this down at the top. Z-score is given. we calculate it like that, and it's based on this formula, just rearranged. We take the z-score times standard deviation plus the mean. That's how we find the actual value. So these two formulas are essentially this, we use this to derive that one and vice versa, okay? All right, so now we're asked to calculate the z-score. We will be using this formula. Okay, so let's go ahead and find that. Oh, sorry, I'm rushing. I don't want to do that. Watch the note, it's very important. The z-score tells us how many standard deviations, right? How many standard deviations above or below the mean you will be, the value is located. A negative z-score, right? Maybe I'll use a different highlighter there. A negative z-score means that the value you're looking at is below the mean. So if your z-score for your test is negative 1.5, that means that you are below the average in the class. Okay, that's what it's telling you. If the z-score is positive, that means that you're above the mean. Okay, so positive z-score, you're above the mean. Okay. Now let's go and calculate this using these two pieces of information. Go to 26J. 26J. Calculate the z-score of a male with a height of 181 centimeters. What does it tell us? So we're going to go z-score is x minus the mean divided by standard deviation. You have to ask yourself, do I know all three of these? And I do, right? I do know my mean and I do know my standard deviation. So in this case, it would be 181. That's the score. That's in this case the height you're considering, minus the mean divided by standard deviation. And I will say this: if you have a fraction and there are operations happening on either one, numerator, denominator, you need to perform those first. So it's as if there are invisible brackets there. Sorry, let's put the number in here, right? We know that this is 2.5. My bad. Okay. So this gets us to, this is 4, right? 181 minus is positive 4 divided by 2.5. Okay, so we go 4 divided by 2.5. That's 1.6. Positive 1.6, I will say. Okay. It tells us that a height of 181 centimeters places you at 1.6 standard deviations above, in this case it's above the mean. Okay. Why is it above? Because of the positive. So you would, if you were 181 centimeters, you would be above average, and specifically 1.6 standard deviations above average. Okay. Determine the height of a male with a z-score of negative 0.4. The negative tells you that the height of this individual, you're following, right? The height of this individual will be below average because negative z-score tells you that. Okay. And so we're trying to find the actual height. So we use this one. That's what we do to find that information, to find the actual height. So we go z-score, which is negative 0.4 times the standard deviation plus your mean, which is 177. And you know what? You can probably do this in one shot, but I will do one step at a time. That's negative 10 plus 177. That's 167 centimeters. Note negative z-score, therefore below average. So 177 is the average height. If your z-score is negative 0.4, that would place you at 167, which is below the average of 177. I feel like I made a mistake there. 0.4 times 2.5 is not 10. Sorry, guys. I made a mistake. Yeah, that's negative 1. Get rid of the 0, and that would put us at 176. My bad. I apologize. I don't even know why I made the mistake, but hey. I just realized 4 times 2.5 is 10, right? Not 0.4. That would not work. But you're still below the average. You're still below the average. Okay. All right. I kind of gave you a whole mix of questions here. Let me just highlight one more thing. One more thing. I would like you to go back up with me to this question right here. You know how you had a z-score of, they asked you, hey, between negative 2 and 1? We knew from our graph that this is 172 and 179.5. We knew that. But if you, let's say you didn't know, right? To find the actual height, we would go z times standard deviation plus the mean, right? So if you have a z-score of negative 2 times 2.5 plus 177, I will type that in one shot. This is negative 5 here. Negative 5 plus 177 is 172 centimeters, right? And that's where you see that everything is connected. You could have just looked at your graph, but you could have also calculated it using the formula I gave you, right? for that one. And you could have done the same thing for this one up here. Okay, same thing if you wanted to, but in this case it wouldn't be necessary, because if you get a whole number for your z-scores, chances are you're going to find it just by looking at the graph. Okay. All right. I want you to try a few, and trust me, guys. The only way you're going to get better at this, understanding the big picture, is trying it. Maybe you will have some struggles, but then I'll come back and then I'll explain it. But here we go. I will just help you with the graph one last time, because the first graph I gave you the template, and I kind of want it to look nice when I ask you the graph. Okay, so grab a ruler. You will answer the questions that follow, but the graph I will help you one last time here. The volume of pop cans is normally distributed. You're like, oh yeah, I know what that means. For large samples. The mean volume is 355 mLs, and the standard deviation is 2.75. Graph a normal distribution curve showing the probabilities for plus or minus 3 standard deviations. Include z-scores. So you want to leave a little bit of room for that labeling underneath, right? And then you just draw a line. And try to use your ruler to help you with this, okay? So I'm going to make this my mean here. I find the center as best as I can. And then I'm going to go up 3. So 1, 2, 3, and I use 2 centimeters every time. This is my mean, and I go 1, 2, 3 marks up, and then I go 1, 2, 3 to the left. Okay. There we go. You put arrowheads on both ends. In this case, it would be the volume of each can in milliliters. And I'm going to put my average down here. So this is going to be my mean, which is 355 mLs. Oh, you don't have to have units, sorry. You're establishing that. Try to save space. This is 355 though. And then you grab your calculator, because these numbers will vary greatly, right? And then you just go 355 plus 2.75. That gets you to 357.75. Plus another standard deviation. That's 360.5. Plus another standard deviation, which is 363.25. Do the same thing going backwards, right? You're going to subtract the standard deviation. So I start with 355. So that's 352. Whatever the calculator gives you, that's what you put down. So this is 349.5. And one more, 3 standard deviations on both ends. There we go. The z-scores that follow, right, would be 0. So if you ever get a z-score of 0, that means that you are the average. You are 0 standard deviations away from the mean, that is the middle. This would be 1, 2, 3, and I line them up, right? You line them up with your values that you just wrote down. Every value has a z-score associated with it. And yes, you can have decimals, right, for something that is in between your markings. This is the easy part. Now making it look pretty is the difficult part. So what I do is I go to the center and I just go up and just make it appropriate with the space you have, and I make a dot there, and then I go to the left, so I kind of go to the side and then down like this, but you never touch the x-axis. Okay, you do the same thing with the go to the other side, out and then down, and technically there are arrowheads on the ends of that curve. And if you use your ruler, it's probably best you section that off. And it shouldn't take you that long after you do one or two on your own. And you just put down the percentages. 34, 34, 13.5, 13.5, 2.35, 2.35. And the 0.15 sometimes is way too small, so I just use arrows for those. And it's percent, everything is percent. Probability under the curve. You don't have to do the 68, 95, 99.7 at the top. That was just for notes, okay? This is all I need. At this point, you are ready to start answering questions. Chances are I'm going to ask you to answer based on your graph if I ask you to graph. Okay. So I want you to answer the questions on 27. Let me just peek on the back side real quick here, because I added some worksheets. I made them just for you here. Yeah, I'm going to say for the rest of today's class, you just keep working. The stop would be page 30, okay? So, and I will come back probably after I feel like most of you are done this page. I will want to stop you and be like, okay, let's look up here. Did you get this right? Keep going, right? So pages 27 to 30 to the best of your abilities, okay? I know this is a new territory, but it's doable. I'm gonna just interject for a bit here, if you don't mind me doing that. Just back to 27, making sure you understood what needed to happen. So volume of more than 360.5, you just add these two numbers, that's 2.5%. A percentage of cans will have a volume between 349.5 and 363, so that's between here and here. You have a choice. You can add up all the percentages from end to end, or you can go 100 minus 2.5. This is 2.5 right here at the end. I took that away, and I'm also taking this away, right? So I'm taking away the ends, which leaves me with 97.35. Regardless of how you do it, that's what you should get. And then this one is tricky. D would be guaranteed 2 marks. Okay. So what I do is I find out the percentage that would have less than 352.25, right? So that's based on the graph above. Let me just show that, right? Right. So this is the percentage of cans that would have less than 352. So that's 16%. And more than 363.25 would just be a small percentage, right? 0.15%. So those are my two that I need to combine, right? Because both of those will be rejected, both of the extremes. So I remove 16.15% of cans. I use that, and no rounding, okay? Use the whole thing times 25 cans. It happens to be exact number, but if it's a decimal, which will happen, you round, okay? You say approximately, round up or down to the nearest whole number. It's up to you. Then the z-score, you just calculate it based on the formula, right? So value minus average divided by standard deviation, you get a negative 0.55 is your z-score. That is okay to have a decimal And then what is the volume given the z-score, right? So if I give you a z-score, use the other formula, right? Just plug it in and you get 358.38 mLs. That's how many, that's the volume that would correspond to a z-score of 1.23. Okay. Keep working. I'll leave this up if you need to see that. Just a correction here for the cans.